Hello, good afternoon. You're welcome to today's class. Tamala Grace, you're welcome. Chika, you're welcome. You're welcome. You're welcome. Okay, so you're welcome. Welcome to today's class. You're welcome to today's class. Okay, we are ready. Please, if you're online, say hi. Hi. You're welcome. You're welcome. Thank you for coming. You're welcome. So we can start. Chika, you're welcome. Good evening, everyone. Welcome to today's class. We are going to look into radioactivity calculations, okay? Yesterday, we were able to define radioactivity, the concept, and radioactive element. Then we went ahead to discuss half-life, decay constant, okay? So, and the relationship between half-life and decay constant. So, but today we are going to look at the calculations under radioactivity. I'm going to give you a formula that we will certainly use to solve problems involving radioactivity, okay? Right. Firi, you're welcome. Joel, just double tap on your screen, give it a thumbs up, okay? So let's start immediately. Terminal Grace, you're welcome. All right, so let's look at this equation on the board. All right, I tag it as radioactivity formula, and we are going to be using it to solve most of the problems on radioactivity. Okay, so the formula goes this way: n over n naught equals 1 over 2 bracket t over half-life. Let me go again. N over n naught equals 1 over 2 bracket t over half-life. Okay, now where n naught, what is our n naught? Original number of atoms before what? Decay, right? Now what is my n? Number of atoms remaining after decay. Okay, then t is time and t half is half-life. So this formula is what we are going to be using to solve problems involving half-life and decay constants. Okay, also involving radioactivity calculation. Half bracket t over t half, okay, is the original number of atoms before decay, and n is the number of atoms remaining after decay. T is time and t half is half-life. So let's see how we are going to use this equation to solve problems. Amanda, you're welcome. Christopher, Amanda, you're welcome. Please copy fast. Let's proceed. Are we done? Grace, done. Okay. Fury, done. If you are just coming, give it a thumbs up. Give it a thumbs up. Let me just set a poll. Okay, Amadi, done. Please give it a thumbs up. So let's move ahead. Favor Ward, you're welcome. Please give it a thumbs up. You are just joining us. Thank you so much. Nnakuzi Onyeka, thank you for coming. If you are just joining us, please double tap, give it a thumbs up. Okay, give it a thumbs up. And make sure you subscribe to this channel. Okechukwu, you're welcome. You're welcome. All right. Let's look at this example. Example 1 on radioactivity calculations. A substance has a half-life of 3 seconds. After 6 seconds, the count rate was observed to be 400. What was its count rate at 0 time? Let me go again. A substance has a half-life of 3 seconds. After 6 seconds, the count rate was observed to be 400. What was its count rate at 0 time? Now, looking at this question, the first thing we are going to do is for us to state our parameters by saying that half-life, which is T half, is equals to 3 seconds. Okay? Then after 6 seconds, that is our time. That is our time. Any time given after half-life becomes what? Time, no longer half-life, okay? So my time, small t, is equals to what? 6 seconds, okay? What was, okay, the count rate was observed to be what? 400. Now, what is this count rate? You know, we have n, and we have n naught. What is n naught? This is the original number of atoms before the atom becomes start decaying or start integrating or start disintegrating rather. Okay, so but after that time, that is at half-life. After that time, the value given or the number of atoms obtained becomes the number of atoms after decay. So with that being said, we now say that the count rate that was observed to be 400 becomes our number of atoms after decay. That is our n. Okay, so we say that n is equals to 400. All right, What was its count rate at 0 time? The count rate at 0 time is n what? N naught, and that is what we're actually looking for. Okay, so for us to be able to do that, we are going to use this equation I just stated to solve our problem by saying that n over n naught is equals to 1 over 2 bracket what? T over half-life. Right? Now for us to do that, we say, what is my n? My n is what? 400 divided by my n naught, which is what I'm looking for, is equals to n naught. Right? Then we say that it is equals to half raised to the power of what? What's my time? My time is 6 divided by my half-life is given as 3. Okay? So when we do that, we are going to divide this to get 2. Okay, let's go. We have 400 divided by what? N naught, then is equals to 1 over 2 raised to the power of what? 6 divided by 3 is going to give me 2. Okay, raised to the power of 2. All right? Now, I will go again by saying 400 divided by what? N naught is equals to, let's remove the power. 1 raised to the power of 2 is equals to 1 over, and 2 raised to the power of 2 is equals to what? 4. All right? So we can say cross multiply. If you say cross multiply, what do we have? We have n naught times 1 is n naught, then 400 times 4. 400 times 4, that means my original number of atoms is equals to 1,600. Okay? Now let me explain again. The question says a substance has a half-life of 3 seconds. Then this is the half-life. I said any time given after half-life is no longer half-life. Or any number of atoms obtained after half-life becomes your n. Because your n naught should be given before your half-life, before the atoms decay. Okay? Alright. So after 6 seconds, that is my time. The count rate was observed to be what? 400. That is my n, because it happens after half-life. Alright. What was its count rate at 0 time? We're looking for n naught. So by stating our parameters and using our formula, n over n naught is equals to what? 1 over 2 bracket T over half-life. With that being said, we substitute into what we have. What is my n? My n is 400 divided by n naught is what? What I'm looking for. Then is equals to 1 over 2 bracket my T is what? 6 divided by my half-life is 3. Okay? Now I'm going to divide it by bringing this one out. If I say 6 divided by 3, it's going to give me what? 2. Now if I have that 2, I'm going to remove this power. 1 raised to the power of 2 is equals to 1. And 2 raised to the power of 2 is equals to 2. Then I'll do cross multiply, and my n naught equals 1,600. I hope you understand that. Right. Cross and farm. Cross farm, you're welcome. Thank you for coming. Please, class, do we understand? Do we understand? If you do, can we put it down? Maria, you're welcome. If you are just joining us, give it a thumbs up. Okay, Chika, you understand? I suppose Chika, I should come again. Okay. Christabel, you do understand, okay? Okay, let me explain again. 3 seconds. Then after 6 seconds, the count rate was observed to be 400. What was its count rate at 0 time? Now, this half-life, I already told you yesterday that half-life is the time taken for an atom to decay to half of its original value. Okay? So if the half-life, for example, is given as 4 years, then after 4 years, the element or the amount of atoms in that element is supposed to do what? Decay into half of its original value, right? And the atom remaining becomes our N, whereas the atom we had before decay becomes our N naught. So with that being said, we now state our parameters by saying that half-life is given as 3 and the time is given as 6. Okay, so my N is equals to 400 and I'm looking for N naught. Now what do? I will put in my formula. N over N naught is equals to 1 over 2 brackets what? T over half-life. Is that okay? All right. So what do we do? What's my N? My N is what? 400 divided by what? N naught, right? Is equals to half bracket. My time is 6. While half-life is 3. Now that is what I have. If I say 6 divided by 3, it's going to give me 2. That's what I have this 2 here. Okay? Then the next thing to do is to remove this power. 1 square is going to give me 1 and 2 square is going to give me 2. Alright? So I'm going to have 400 over n is equals to 1 over 4. Okay? So I do cross multiply. If I do cross multiply, what do I have? I'll say 400 times 4 is going to give me what? 1,600. And that becomes my original number of atoms before decay. Is that okay now? All right. Are we done writing? Let's move to the next one. Bright, you're welcome. Please give it a thumbs up if you're just coming. Okay, let us solve. A radioactive element is actually a jam question. A radioactive element has a half-life of 4 days. Okay, The fraction that has decayed in 16 days is what we are looking for. What is the fraction that has decayed in 16 days? Let me go again. A radioactive element has a half-life of 4 days. The fraction that has decayed in 16 days is what? So let's go. My half-life is equals to 4 days. Then the fraction is what you're looking for, but they give us time. Time is what? 16 days. You're looking for the fraction. Which fraction are you looking for? You're looking for n over n naught. That is the fraction that you're looking for. Okay? You're looking for this fraction that has decayed. That has decayed. So the first thing we need to do is for us to get the fraction that was remaining. Then we can now subtract to get the fraction that has decayed. So let's dive into it. Right? We have our formula n over n naught is equals to half bracket t over half-life. Okay? Now what's my n? I'm looking for n over n naught. That is a fraction. So n over n naught is equals to, this is 1 over 2 bracket. What is my t? My t is what? 16 divided by my half-life is what? 4. Is that okay? So let's solve again by saying n over n naught is equals to 1 over 2 bracket 16 into 4 is going to give me what? 4. Okay, so I have what? 4. So what do I do next? I'm going to open the bracket by raising this to the power of 4. So that is n over n naught is equals to 1 raised to the power of 4 is equals to 1 divided by 2 raised to the power of 4 is equals to what? Is equals to what? 2 times 2 times 2 times 2. What do we have? I have 16. Okay? 2 times 6, 2 times 2 times 2. 2 times 2 times 2 times 2, right? Okay. 2 times 2 is 4. 4 times 6 is 8 times 2 is what? 16. So that is 16. Now, this fraction we have gotten now is not the fraction that decayed. This is not the fraction that decayed. This is the fraction that is remaining. This is the fraction that is remaining. So we need to get the fraction that has decayed. And because it's a fraction, how do we get the fraction that has decayed? I will now say, okay, the fraction that decayed okay, is equals to n over n naught is equals to 1 minus 1 over 16. Okay? 1 minus 1 over 16. Now, if you want to take it further, this should be over 1, right? For me to get the LCM, I'll get the LCM to be what? 16, right? 16 divided by 1, I'm going to have what? 16. 16 times 1, what do I have? I have 16. So this is 16 minus, okay? 16 into itself, 1. 1 times 1, I have 1, right? So, n over n naught is equals to, when you subtract 16 divided by 1, going to give me what? 15 over 16. So this is the fraction that what? Remain. I will just say fraction remained. This is the fraction that remained. Okay? Do you understand? Now let me explain again. If you are asked to find a fraction, sorry, this is the fraction that decayed. Sorry, this is the fraction that decayed. If you are asked to find a fraction that decayed, you are going to solve with our formula. Whatever thing we have is not the fraction that decayed. It is the fraction that remained after this integration. It is the fraction that remain after disintegration, because all the element that has decayed, you cannot find it. You can't find it. So the one we have is one remaining. So for us to know the one that has decayed, we're going to say, because this is a fraction, and we have whole number that is greater than a fraction. So we say 1 minus 1 over 16. Use LCM to solve, to get it as what? 15 over 16. So this is the fraction that decayed. Whereas this is the fraction that does what? That remain. Do we understand? All right. Please, do we understand? Do we understand? If you do, please put it down. Let's proceed. If you are just joining us, give it a thumbs up. Okay, KHP understood. What do you understood? Okay. Okay, Christopher, you understand? Okay. Maria, done. Are we done? Let's move to another one. Are we done? Maria, done. Are we done? Amanda, done. Okay, Chiku, done. Okay. Oh, they are still writing. All right. Fury, done. Okay. Grace, done. What are you done? Let's proceed. Okay. All right. So let's look at this example. A sample of radioactive material has a half-life of 35 days. Okay? Calculate the fraction of the original quantity that will remain. Calculate the fraction of the original quantity that will remain after what? 105 days. The last, but this one says what? Remain. All right, so let's see how you're going to do that. Now you're just given these two parameters, the half-life and the time. And if you're looking for fraction, the fraction we are looking for is n over n naught. So let's dive into it. Now my half-life is given as 35 days. Okay, so my time is given as 105 days, right? What are we looking for? We're looking for the fraction of the elements that will remain. So I'm looking for n over n naught. Okay, that is what we are looking for. So let's use our formula by saying n over n naught is equals to 1 over 2 bracket t power over what? Half-life, right? I'll go again by saying n over n naught is equals to 1 over 2 bracket. What's my time? My time is 105 divided by my half-life is 35, right? So we proceed by saying n over n naught is equals to 1 over 2 raised to the power of 105 divided by 35. What do I have? 105 divided by 35. I'm going to have 3. So I have raised to the power of what? 3. Okay. Then this is the same thing as 1 power 3 over 2 power 3. Right? Then going by that, we are going to say 1 into 3 is going to give me 1. And 2 into 3 is going to give me what? 8. It's the same thing as saying 2 times 2 times 2, right? So that is going to give me what? 8. So this is the fraction that remains after what? Decay. Okay? Because anyone we got as our answer because the one remaining. But you want to look for the one that has decayed. You're going to say, because this is a fraction, you're going to say 1 minus what you have to get the fraction that's what? That has decayed. But since in this question we're asked to find the fraction that remains, this is the fraction remaining. I hope you get it right. Please, do we understand? Fury, Grace, Wadi, Amanda, do we understand? If you do, copy down the note. Let's proceed. Fury, you are done. Okay, Amanda understood, okay? Christabel understood. Maria understood, okay? Okay, are we done? Are we done writing? Comfort, you are done. You are just joining us. Please give it a thumbs up and make sure you subscribe to this channel. All right, so let's proceed to the next one. Okay, can you copy fast? Let's proceed. Are we done writing? Hey, Socha, you're welcome. Please give it a thumbs up. Okay, let's solve this problem together. 4 grams of a radioactive material of half-life 10 days is spilled on a laboratory floor. Let me go again. 4 grams of a radioactive material of half-life 10 days is spilled on a laboratory floor. How long would it take to disintegrate 3.5 grams of material? What are we looking for? Time. Okay? From this question, the number of atoms before decay, that is N0, is equals to 4 grams. Okay? Now going by that, we are given the half-life to be 10 days. And they ask us to find how long, that is time, to disintegrate 3.5 grams of this material. The word disintegrate, what does it mean? Disintegrate, what does it mean? To decay. To do what? To decay. So this is the same thing as saying decay. To decay 3.5 grams of the material. Are we getting it? So if 3.5 grams of the material should decay out of 4 grams, how many will remain? That becomes the mass remaining. Do we get it? So let's go there. I have the number of atoms before decay is equals to 4 grams. Okay? So now my N, which is number of atoms after decay, will be what? 4 minus 3.5. It's going to give me 0.5 grams. Do we understand? Okay. Then the half-life is giving us 10 days. And I'm asked to calculate what? The time. So how do I do that? I'm going to use my formula to solve. Okay, so I say N over N naught is equals to 1 over 2 bracket T over what? Half-life, right? So what is my N? My N is 0.5. I can still make it to be a fraction. 0.5 is the same thing as saying, is it 1 over 2? Okay, that is 1 over 2. All right. So I can say 1 divided by 2, right? Then divided by my N naught, which is what? 4. This is equals to 1 over 2 bracket. Hold on. Okay, what? You're unable to get the last question because of network. All right. After the class, I will send it on the group, okay? So you can actually watch it from there. All right. So this is my half-life, okay? Now, what is my time? I'm looking for time. But the half-life is giving us what? 10, okay? Now, if you want to split this again, this is the same thing as saying 1 over 2 times, right? This is going to come down by saying 1 over 4, okay? Then it's equals to 1 over 2 raised to the power of T over 10. Do we understand? 1 times 1 is 1. 2 times 4 is what? 8. Now this is equals to 1 over 2 raised to the power of what? T over what? 10. Now what I'm going to do next, I want to make this to be in the same form like this. Right? Okay. All right. If I want to change this to be in the same form or the same nature with this one, what do? I would say this is 1 over 2. Okay? 2 raised into power of 3 is going to give me 8. And 1 raised to the power of 3 is going to give me 1. So I'm going to say 1 over 2 raised to the power of what? 3, right? Is equals to 1 over 2 raised to the power of what? T over 10. Right? Now this is common. I'll cancel it. Right? So I'm left with what? 3. This becomes 3 is equals to T over what? 10. Right? Because I'm looking for time, I'll say this is over 1 cross multiply. Okay? Now, this is going to give me what? T times 1 is T. Then I have 3 times 10. My answer is going to give me what? 30 what? Days. So the time that I'm actually looking for is equal to 30 days. Do we understand? Right. Please, do we understand? Okay, Annabelle, you understand, okay? Okay, are we put done? Are we done? Pearl, you're welcome. Okay, please double tap on your screen. Give it a thumbs up, okay? Hold on. I want to fix something. What they are done? All right, let's move into another one. Sorry, I'm trying to adjust this so that I can see clearly. Okay. Matthew Okechukwu, you're welcome. Thank you for coming. I really appreciate. Okay, so this is your classwork. I want you to attempt it. Let me see whether you understand what you're doing. All right, Fury, are we there? Odi, are we there? Osakwe, are we there? Are we still solving? Okay, Fury, 15/16, your answer, okay. Are you done? What's the answer? Okay. Ephraim George, 15/16. Bright, 15/16. Christabel, Osakwe, 15/16. Deima, okay. This is SS3 class. Deima. You're in which class, please? Maria, 15/16, okay. Deima, you're in which class? Osakwe, what's your answer? Joel, 15/16, okay. Deima, which class are you? SS1, okay. I did not do live SS1 today, but I sent them a video on measurements of physical quantity, so you can go and watch it and do the assignment there. Okay, I didn't go live for SS1 today because I was not around, okay. Eagles Corner, hello, you're welcome. Thank you for stopping by. Thank you so much. I appreciate. God bless you. All right, class, let's solve the question on the board. Okay, the half-life of a radioactive element is 9 days. Okay, what fraction of the atoms has decayed in 36 days? Now, for us to do that, our half-life is equal to 9 days. Okay, then the time given is 36 days. Now, what fraction are we looking for? The fraction we're looking for is n over n naught, right? That is what we're looking for. We're not looking for the fraction that remain. We're certainly going to get the fraction that has remained. After which we'll now solve for fraction that has what? That has decayed, right? Okay, let's go. We say n over n naught is equals to 1 over 2 raised to the power of t over half-life, right? Okay, so let's put in what we have. N over n naught is equals to half bracket. What's my t? My t is 36 divided by my half-life is what? 9. Okay, so we go back to say n over n naught is equals to 1 over 2. Okay, 36 divided by 9 is going to give me what? What do I have? I have 4. So if I have 4, what next? This is the same thing as saying 1 raised to the power of 4 over 2 raised to the power of what? 4. Because I want to open the bracket. Then I have n over n naught is equals to 1 raised to the power of 4 is equals to 4. And 2 raised to the power of 4 is equals to what? 8. This is the same thing as saying 2 times 2 times 2 times 2, right? Okay. Okay, so I have 16. I have 16, okay? This is 2 times 2 times 2 times 2, right? 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Now, this is the mass of the atom that remain after decay. But that is not what we're asked to do. We're asked to find the mass that what? That decay. So because this is a fraction, the fraction, what I'm looking for is what? Fraction decayed. Fraction decayed is equals to 1 minus 1 over 16. Of course, I'm going to get what? 15 over 16. So this is the fraction that has what? That has decayed. We all got the answer to be 15 over 16. Okay? All right. Restart. Now the fraction, you are looking for the fraction that decayed, not the fraction remaining. Okay? The fraction remaining is 1 over 16. Okay? But the fraction decayed is 1 minus 1 over 16 to get 15 over 16. Right? Now, Deima, your class is by 2. SS1 is by 2. Okay? It's SS2 that I teach by 11. Osakwe SS2 is by 11. Okay? All right. Now, can we move to the next one? I hope you understood this now. Let me try with another question to see how you'll be able to solve it. Can we move to the next one? Amanda, Okorafo, Ephraim George, are we there? Can we move to the next one? All right. All right. So I want you to look at this question on the board and see if you can be able to get the answer. Okay. All right, I'm waiting for your answers. Are we solving? Please, can we send in our answers? Ephraim George, 24 days, okay? Please, can we send in our answers? Let's see if you are correct. Fury, 24, okay? Amanda, are you still there? Bright, 24. Bright, Daniel, are you Bright Ochia, please? Daniel Bright, are you Ochia Bright? Comfort, 24, okay? Maria, 24. Joel, 24. Okay. All right, Bright, you're welcome. So let's solve. nuclide of mass 6 grams has a half-life of 8 days. Calculate the time during which 5.25 grams of the nuclide would have decayed. Now, the first thing I'm going to do is to look at our number of atoms. That is the original number of atoms, okay? It is given as 6 grams, and the half-life is given as 8 days, right? And this is the number of atoms that has decayed. So we need to get the number of atoms that is remaining after decay. That is by saying 6 minus 5.25, okay? So let's dive into that. All right, let's go. My N naught is equals to 6 grams, okay? Then half-life is given as 8 days. They are asked to find the time, all right? But how do we get our number of atoms remaining? So I'm going to say 6 minus 5.25, and the answer becomes what? 0.75 grams, right? And if I want to let it be in fraction, the same thing as saying 75 over 100, right? Grams. So if I use our formula, we have N over N naught is equals to half bracket T over half-life, right? With that being said, what's my N? My N is 75 over 100, right? Divided by 6 is equals to 1 half bracket. My T is what I'm looking for, and my half-life is 8, okay? So what I'm going to do now is to say 75 over 100 times 1 over 6, then is equals to 1 over 2 bracket T over 8, right? Now what can go? 2 can go into this, 3 can go into this. I have what? 2, okay? 3 can go into this. I have 2 into here. When one add it here, I have 5, right? So this is 25 over 100 times 1 over 2 is equals to 1 over 2 raised to the power of T over 8. Now this divide is to give us 1. 25 into itself 1, 25 into 100, 4. 1 times 1 is 1, 4 times 2 is 8. So this is 1 over 8 bracket T over 8, all right? I can decide to make it to be in this form by saying that this is 1 over 2 raised to the power of 3 is equals to 1 over 2 raised to the power of T over 8, right? With that being said, this will cancel this, right? So I have 3 over 1 is equals to T over 8, right? So I'll say cross multiply. If I say cross multiply, T times T is T, while 3 times 8 is what? 24 days. Do we understand that? So this is how we can solve this problem on radioactivity. Okay? So I'm going to give you one more question to try to test your ability. Right. All right. So let's look at another question. All right. I want you to look at this problem and see if you can attempt it. All right. You can solve and send in your answers. I'm still waiting. Are we done? Fury. 7.5. Are you sure? All right. Let's see. $30. Ephraim George. Okay, 20 years. Okay. All right. I'm waiting for your answers. Okay. Bright. Maria. Grace. Osakwe. Awonaya. I'm waiting for your answers. Okay, Pay, you got 20. Okay. All right, should I solve? Is the question tactical? Godwin, 20 years, 7,300 days, okay? Right, 20 years, okay? Maria, you think it's 20. That means you're not sure. Also, 20 years. Okay. Fury, we are getting another thing. Okay, let me solve it so I can get it right. Okay. Okay, let's go. If the fraction of the atoms of a radioactive material left after 120 days, left after 120 days, 120 years is 1/64. What is the half-life of the material? Let me go again. If the fraction of the atoms of a radioactive material left after 120 years is 1/64, okay? What is the half-life of the material? Okay? So, for us to solve this problem, you should know that the time given is 120 years, and half-life, which is T half, is what we are looking for, right? Okay, but this fraction is the fraction that left. Now this is, okay, sorry, my n, that's the fraction of the material left, and left is n, okay? Let me say my n naught still remains my original number of atoms, okay? Then my n is 1/64 of what? The original number of atoms. Is it clear what I just did? My original number of atoms remains the same, but the atom remaining, that is the atom left, the fraction of the atom left, okay, is 1/64 of the original. So if you go by that, this is going to give me what? 1/64 times what? N naught, okay, which is going to give me N naught over 64. Is it clear? All right, this is our formula. N over N naught is equals to 1/2 bracket T over half-life, right? What's my N? My N is N naught over 64, right? Divided by N naught. Then is equals to 1/2 bracket, what's my time? 120. What's half-life? That is what I'm looking for, okay? Then this will be N naught n naught, right, is equals to 1 over 2 bracket 120 over half-life. Now this will cancel this, right? And I'm left with 1 over 64 is equals to 1 over 2 bracket 120 over half-life. Okay? Now I want to change this 1 over 64 to be in the power of this. So what do? How many times are you going to raise 2 to be 64? This is 1 over 2 bracket. Let's go. Let's try. 2 times 2 times 2 times 2 times 2. Okay, let's go. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is what? 32. 32 times 2 is what? 64. So you have how many? 1, 2, 3, 4, 5, 6. We are raising 6 2 into power of what? 6. All right? To be able to get 64. So this is power 6 is equals to 1 over 2 raised to the power of 120 over half-life. Now half cancels half. Okay? So I have 6 is equals to 120 over half-life. Right? This is over 1. I can say cross what? Multiply by saying 6 half-life is equals to what? 120. I will now divide both sides by what? By 6. Automatically, my half-life is equals to what? 20 years. Do you understand? Right. Ephraim George, so I should explain again. Okay. Okay, let me go again. If the fraction of the atoms of a radioactive material left after 120 years is 1 over 64, okay? What is the half-life of the material? Now, the time given is 120 years. They're looking for half-life. They did not give us the original number of atoms, but they gave us the fraction of the original number of atoms left after decay. So since you are not given, we now assume that our original number of atoms, n naught, is still equals to n naught. Okay? With that being said, what's my n? My n is the number of atoms left or remaining after decay. All right? So they gave us the fraction, which is 1 over what? 64 of what? The original number of atoms. Now, this is 1 over 64 times what? N naught. By the time you multiply, it becomes n naught over what? 64. That becomes my n. Now I'm coming to the formula. I have my formula as n over n naught is equals to 1 over 2 raised to the power of t over t half. Right? Okay. So what is my n? My n is n naught over what? 64. Right? Divided by n naught. Then it's equals to 1 over 2 raised to the power of what? 120 over t half. Okay, so this is equals to n naught over 64. If I change this sign, I'm going to take it over by saying 1 over what? N naught, right? N naught cancels n naught. I'm left with what? 1 over what? 64, right? So I have 1 over 64 is equals to 1 over 2 power 120 over half-life. Now, I want to remove this 64 and make it to be in power of what? Of 2. So how many times am I going to multiply to get 64? And we worked it out to do that into how many times? 6. So 1 over 2 raised to the power of 6 is equals to 1 over 2 raised to the power of what? 120 over half-life. Do you understand? All right. So what am I going to do? This is now the same. So there's this for me to cancel. I cancel them and left with what? 6, which is equals to 120 over what? T half. Then I will say this is over 1. Then I do cross what? Multiply. 6 times T half is going to give me 60 half. Then 120 times 1 is going to give me 120. Okay? Then I divide both sides by the coefficient of half-life. Because that is what I'm looking for, which is 6. So I'm going by 120 divided by 6. The answer becomes what? 20 years. Do we get it? Right. Do we understand? Okay, when you change your years to days, by the end I will multiply to get. Okay, no. One night, depending what you are giving, if the time is given in years, your half-life is supposed to be in years. Okay, if you look at what you have been solving, you realize that half-life does not have a fixed unit. Depending on the question given. If the half-life is given in years, your time will be in years. But if the half-life is given in days, your time will be in days. Okay? All right. I hope you all got it now. What if you still change it to years at the end? You are still correct. Okay, you are still correct. Please, if you are just joining us, give it a thumbs up. Okay, please give it a thumbs up. You are still correct. But depending on the nature of the question, if it's given in years, let it be in years. Okay, let's try this last one. Let's try this last one. Okay, are we done writing? Okay, so we are done. Maria, are done. Okay. Fury, are you done? Wadi, are you done? Are we done? I want us to solve the last example for today so that we can call it a day. Are we done? Fury? All right, so let's go to the next one.
All right.
All right, we can try this and see what you're going to get as your answer. All right, I hope you are solving. All right, are we solving? Okay. Fury, are you done? Ephraim George done? Maria done? Bright done? Ogbonnaya done. Osakwe done. Are we done? If you are just joining us, please give it a thumbs up. Okay, Ogbonnaya have 4 days, all right? Yes, keep it coming. Okay, Pay got 4 days, right? Fury 4 days, okay? Maria 4 days, okay? Bright 4 days, okay? All right, let's solve together. Okay, so let's go. The question says, in 24 days, a radioactive isotope decreases in mass from 128 grams to 2 grams. What is the half-life of the radioactive material? Let me go again. In 24 days, a radioactive isotope decreases in mass from 128 grams to 8 grams. What is the half-life of the radioactive material? Now, for us to solve this question, the time given here is what? 24 days, right? Okay, then there's a decrease in mass from 128 grams. That is the what? The original number of atoms is equals to 128 grams, okay? Then to this, 2 grams. This 2 grams becomes my what? My N. Okay, so what is my half-life? That's what we are looking for. All right. Okay, so going by what we have, we say that my N over N naught is equals to 1 over 2 bracket T over half-life. Okay, what's my N? My N is what? 2, right? All right, divided by what? 128. Then is equals to half bracket T over T half. right? Okay, let's see what we have. Okay, we are going to divide by saying 2 into itself 1, 2 into itself 1, 2 into 128. I'm going to have what? 64. So this is 64, right? Okay, what's my time? My time is 24 over half life is what? Is what I am looking for. All right, so how many times will you raise 64 to be in the power of what? 2. Okay, guys, 2 times 2 times 2 times 2 times 2, right? 2 times 2 4 times 2 8 times 2 16 times 2 32, and times 2 is what? 64. That is how many? 1 2 3 4 5 6. All right, so we have 2 raised to the power of what? 6. Okay, so I have this is 1 over 2 raised to the power of what? 6 is equals to 1 over 2 raised to the power of what? 24 over what? T half, right? This cancels this. This is 6 over 1 is equals to 24 over T half, right? Now, for me to get time, my time is equals to 24 over what? 6, right? And my answer becomes what? The half-life is equals to 4 days. Do we understand? Right. Fury, what's that all about? Please stop. I don't want that. Fury, I don't want that. Obonnaya, I don't want that. Okay? Stop it, oh. This is final warning. All right. Do I still give another class work? Or should we end the class here? With an assignment. Fury, do you need another class work? We are no Obonnaya. Assignments, okay. Let's give assignments. Bright, you need another class work with assignments. Fury, is dining time. Okay. All right, let me give assignments, okay? So that Fury can go and eat. You say it's dining time. All right, take down your assignment for today. All right, take down your assignment, okay? So we can close the class for today. Take down your assignment. Please take down your assignments so we can end the class for today to come back tomorrow. Okay, Bright done. Phoebe, Maria done. Ephraim George done. Okay. Please, if you know that I'm not subscribed, please subscribe to this channel. Okay. You can also follow me on TikTok and Facebook with the same name. Okay, Jossy Science Academy. Okay, that would be great. I'll be hoping to see you people there. Ephraim George, you're done. Okay. Amanda has gone. Is she still here? Maria done. Comfort done. All right. So we are going to end this class now to come back tomorrow same time. Drill done. Okay. All right, thank you everyone for sticking to the end of the class. I hope you enjoyed today's lesson. All right, make sure you do your assignments, okay? The more you solve, the more you learn physics better. See you next time in the next one. Bye. How will I change from 1/33 to 1/2? Work it out. That is why it's an assignment. Work it out, okay? That is why it's an assignment. Okay, so try it. Let's see how it goes. The people are just joining us now. Wow, where are they coming from? Please double tap on your screen and give it a thumbs up. Okay, we're about to end the class. Give it a thumbs up. All right, so I'm going to see you people tomorrow, same time. See you next time.